Hi guys, second video. Here's what I'm on this slide. I'm worried about these guys. Okay, these guys over here. If we need to come back and do some more problems like that, you can let me know in class. It's not a problem. But I'm mostly worried about what happens when we get an I that shows up down in a denominator on this slide. We have to rationalize. Okay, because remember, I is a square root. Anytime you have a square root in the denominator, you got to get rid of it and rationalize things. Okay, so I'm primarily concerned about the rationalization in this video. Okay, again, remember, going back, okay, when you're talking about algebra, whether algebra 1 or algebra 2, and if you ever had something like, I don't know, 12 over, the square root of 3, you can't leave it that way because in a reduced fraction, we can never have a radical down in the denominator. So you got to get rid of that radical. So to get rid of it, we would have to multiply the denominator by 3 because square root of 3 times square root of 3 is just 3. And so going all the way back to middle school work with fractions, if we want to come up with an equivalent fraction, whatever we multiply the denominator by, we'd have to multiply the numerator by. And so we would get 12 times the square root of 3 all over radical 3 times radical 3 is just 3. And then since these guys are outside the radical, you can reduce them. 12 divided by 3 is 4, so this will reduce down to 4 radical 3. So this guy right here numerically is the same as this guy. They have the exact same numerical value. It's just that we can't give that as an answer because it's not reduced. Okay, it's not rationalized because we have a radical down below. So the same thing happens here because you have an I down below. And remember, I is the square root of 1. So you have a square root down there. So you have to deal with it. You have to rationalize it. Okay, so let's see that first one. Okay, we have 8 over 5I, like that. Okay, 8 over 5I. Now remember, okay, guys, this means 8 over 5 times the square root of negative 1. That's what it means. Okay, so to rationalize that, I'd have to multiply above and below by the square root of negative 1. Square root of negative 1 like that. Now, we don't like to work with this square root of negative 1. We want to leave it as I. Okay, so I'm just going to work in terms of I. Okay, so I would take this 8 over 5I, and I got to multiply. Notice I'm multiplying above and below by I. So multiply by I, multiply by I. Okay, so I'm going to get 8I up above, and down below I have 5 times I squared. Now remember, I squared is negative 1. Okay, so this is 8I over 5 times negative 1. Okay, so we're going to get 8 over negative 5. Now, as a mathematician, we hate having negative signs down in the denominator. So you never leave it, I'm sorry, there's an I up there. You never leave it down in the denominator. So you got one of two choices. This guy either goes up above or it goes out front. Doesn't make any difference. I have a tendency to put it up above. So I would present my answer as negative 8I over 5. Okay, so I've taken this guy, I've rationalized it, and that's what I get. Okay, numerically, they're exactly the same, but this isn't rationalized. Okay, so we take that second one. Okay, and I have 10 over 7I. Okay, so notice this guy and this guy, it's almost exactly the same, just different numbers. Okay, so you say, okay, how did I rationalize this guy? I multiplied above and below by I. So I'm going to do the same thing here. Multiply below by I, which means I multiply above by I. Okay, so that gives me 10I over 7I squared. Okay, and remember again, I squared is negative 1. So I'm going to get 10I over 7 times negative 1, which is negative 7. And again, get that guy out of there. Okay, don't want to leave it down below. So I'd write it as negative 10I over 7. Okay, got the first two done. Okay, let's see that next one. Number 3, we have negative 3 over 10i. Negative 3 over 10i. Okay, now notice you take a look here, here, and here. Notice they're all basically the same, just different numbers. Okay, so again, I have to get rid of that I down below by rationalizing. So multiply below by I, which means I have to multiply above by I. Okay, so I'm going to get a negative 3i up above. Down below, I get 10 times I squared. Okay, so I have a negative 3i over, that'd be 10 times negative 1, so that's negative 10. And notice these negatives cancel each other out, so we just get 3i over 10. Okay, got that guy done. Let's see, the fourth one. 2 over 3i. Well, again, very similar to this one, and this one, and this one. So multiply above and below by I. Okay, so I'm going to get 2i over 3i squared. Okay, now I squared is negative 1. So this is 2i over 3 times negative 1 is negative 3. And again, get that guy out of there. Move it out front or up above. So we get negative 2i, negative 2i over 3. Okay, and we're good there. Okay, all right, now, number 5 and number 6 are slightly different, okay, because notice up above I have a binomial. Okay, notice over here it's just one term, a monomial, a monomial, a monomial, a monomial, just one term. Now I have two terms, so I get a binomial, I have two terms, I have a binomial. But notice that the denominators here are really similar to these denominators over here, like this. Okay, so it looks to me like I would have to multiply above and below by I here, multiply above and below by I here. It's just that when I go up above in the numerator and have to multiply by I, it's I times this whole binomial, I times this whole binomial, so I'll have to use the distributive property. Okay. So let's see what we got going on here on number 5. Okay, it is 4 plus 3i all over the opposite of I. Okay, now remember, this opposite of I, remember what that means. Okay, that's the same as negative 1 times I. That's all it is. 4 plus 3i. So notice that this denominator here, pretty similar to that guy, pretty similar to that guy, pretty similar to that guy, pretty similar to that guy. So really all I have to do is multiply above and below by I. Okay, so I've got this I, I've got this I. Okay, so now up above, notice I'm going to have 4 plus 3i, and I have to take that entire thing and multiply by I, which means I'm going to have to use the distributive property. Okay, down below, I have negative 1 times I squared. Okay, so let's see, I distribute this. 4 times I is 4i, plus 3i times I is 3i squared. And then down below, I've got that negative 1, the original coefficient, and I squared is negative 1. Okay, and then we just finish it up. So let's see, this would be 4i. All right, 3 times I squared. I squared is negative 1, so 3 times negative 1 is negative 3, so just 4i minus 3. And then down below, notice you're going to get negative 1 times negative 1, which is positive 1. And we have a denominator of 1, so we just drop it off. And this is just 4i minus 3. That's all it is. Okay, so far so good. Let's try another one that's very similar to that. This last one, number 6. Okay, so I have 7i minus 9 all over 6i. Okay, so again, just like all of these, because look at all the denominators are very, very similar. So I got to get rid of this I, so I just multiply by I down below to get rid of it, which means I have to multiply up above by I. Okay, so up above, I'm going to have the binomial 7i minus 9 times I, and then down below I have the 6, and I times I is I squared. Okay, so let's see. Distribute up above. Okay, so I'm going to get 7i squared minus 9i, and then down below I'd have 6 times negative 1, which is negative 6. Okay, so let's see. What am I going to do here? Okay, so let's see. Up above, 7 times I squared. I squared is negative 1, so 7 times negative 1 is negative 7 minus 9i. We know we don't like this guy, so bring it up above. But when you bring that negative up above, it has to apply to all of the numerator, which means I'm going to have to distribute it. Okay, so remember that negative sign means a negative 1, so negative 1 times negative 7 is 7. Negative 1 times negative 9i is positive 9i, all over 6. And we got our answer, and we're in good shape. Okay? So just rationalizing with complex numbers. Okay? I know you did a little of this in Algebra 2. Okay? So it should be primarily review. So let's see what we got going on in this next one. Okay, now, this is where things get a little different. Okay, because if you take a look at these, notice how down below I have a binomial. Okay, it's and a binomial, and a binomial, and a binomial. Okay, these denominators are all binomials. Over here, they were all monomials. Okay? All right, so you say to yourself, well, why would it make a difference? Who cares? Well, it makes a difference. For instance, let's suppose we took that first one. And I said, okay, let me just do it the same way we've been doing it. Okay, and so I take that first one, and I have 2 minus I over 3 plus 2i. And I say, okay, well, let me just multiply down below by I, which means I have to multiply above by I. Okay, now watch what happens down below. I have a binomial times a monomial, so I distribute. So I get 3i plus 2i squared. And notice what happens here. I get 3i, and that would be 2 times negative 1, which is negative 2. And notice that I still have an I down below. And so when I try to rationalize just by multiplying by I still got an I down below. And I can't have that. Okay, I can't have any i's down below because that means I have a square root, okay, down in the denominator. Okay, so this method on itself isn't going to work. And so what we have to work with are conjugates. Okay, so if you have two binomials, and this, whether we're in the complex number system or not, it doesn't make any difference. But in general, if you have two binomials that are exactly the same other than the signs, those are called conjugates of one another. Okay, and since we're working in the complex number system, okay, we would have an I in both of them. So A plus BI and A minus BI, they're called conjugates. It's just that they're complex conjugates. But notice how these two binomials are exactly the same other than the signs. Okay? So anytime you multiply a pair of conjugates, now that could happen when they're complex or it could happen when they're not complex. But anytime you multiply a pair of conjugates, you always get a difference of squares. Okay, so for instance, if I just take this, if I take A plus BI and multiply it by A minus BI, I'm going to get a difference of squares. Okay, and the O's and the I's from the FOIL method cancel each other out. I never use the entire FOIL method on conjugates because I know the O's and I's will cancel each other out, but I'll show you that it does happen. So notice if you go A times A, first times first, you get A squared. If you go outside, A times negative BI, that would give you negative ABI. And if I go inside, BI times A, I get a positive ABI. And then if I go last, positive bi times negative bi, I'm going to get negative bi squared. And notice right here, they cancel each other out. The O's from right here and the I's from right here from the FOIL method are opposites of each other. That's going to happen anytime you multiply conjugates. So notice we're going to get a squared, okay? And notice this guy right here minus, that would be b squared times I squared. And I squared is negative 1. So I get a squared, that'd be negative b squared times negative 1, so that's b squared. Positive b squared. And notice that a difference of two squares when you're in the complex number system becomes a sum of two squares. But this notion of conjugates giving you a difference of two squares gives us a method for rationalizing these types of problems. Okay, so let's see, we take that first one. Okay, and I have 2 minus I over 3 plus 2I. So I can rationalize this, and notice the denominator is a complex binomial, by multiplying by its conjugate. Now the conjugate of this is just that binomial, just change the sign in between. Okay, so I multiply by 3 minus 2I. So if I multiply down below by 3 minus 2I, I got to multiply up above by 3 minus 2I. Okay, and so we say, okay, up above, notice that you have two binomials, and they're not the same, so it doesn't form a difference of squares, so you got to use the FOIL method. Okay, so let's see. First times first, 2 times 3 is 6. Outside, 2 times negative 2I, that's negative 4I. Inside, negative I times 3, that's negative 3I. And then last, negative I times negative 2I, that's positive 2I squared. Now down below, when I do the FOIL method, the O's and I's will cancel each other out. So I just have to go first times first minus last times last. Okay, so I go 3 times 3, okay, or 3 squared, minus 2I times 2I, or 2I squared. Okay, it's a difference of squares. First times first minus last times last. And then we just simplify. Okay, so let's see up above. 6 minus negative 4I minus 3I, that's negative 7I. And then this is 2 times I squared, and I squared is negative 1, so that's 2 times negative 1, or negative 2. Okay, down below, 3 squared is 9. Okay, now when I square 2I, I have to square the 2, so that gives me a 4. And then square the I squared is negative 1. Okay, and then we keep going. Okay, so let's see, up above, 6 minus 2 is 4. So that's 4 minus 7I. And then down below, notice I'm going to get 9. Negative 4 times negative 1 is positive 4. So notice I'm going to get 4 minus 7I all over 13. We have what we need. Okay, so let's see that second one. All right, 3 over 5 minus 4I. Okay, so once again, that denominator is a complex number, but it is a binomial. So I got to multiply by its conjugate. So take that binomial, just change the sign to get its conjugate. So that's 5 plus 4I. So if I multiply down below by 5 plus 4I, I have to multiply up above by 5 plus 4I. Okay, so let's see. All right, now up above, notice it's a binomial times a monomial. That only has one term. So that's just a distributive property. So we just distribute it here. Okay, I don't have to use the FOIL method. So 3 times 5 is 15. 3 times 4I is 12I. And then down below, I know that the O's and the I's cancel each other out. It gives me a difference of squares. So I take the first term, square it, minus the second term squared. and now I just simplify. Okay, so I've got 15 plus 12i, and then down below 5 squared is 25, minus, this would be 4 squared, which is 16, times I squared, which is -1. Okay, so I am going to get 15 plus 12i all over. Notice this will be 25, and then -16 times -1 is +16. So I get 25 plus 16, which is what, 41? And we're good. And there you go, it's rationalized. Okay, let's try another one. See that third one down. 6 plus 7i over 1 minus 2i. Okay. Okay, again, notice I got a binomial down below in the denominator, so I got to multiply by its conjugate. So the conjugate of 1 minus 2i would be 1 plus 2i. So if I multiply down below, I got to multiply up above by the same thing. Okay, so now when I go up above, notice that I have a binomial here times a binomial here. That's the FOIL method. Okay, so this is like this top one. Okay, so if I go first times first, 6 times 1 is 6. Outside, 6 times 2i, that's 12i. Inside, 7i times 1, that's 7i. And then last, 7i times 2i is 14i squared. Okay. Down below, notice the o's and i's will cancel each other out. So I just take the first term and square it minus the second term and square that. Get a difference of squares. Oh, sorry guys. Okay, so let's see, let's simplify. Okay, so I've got the 6. 12i plus 7i is 19i. Okay, this would be 14. I squared is -1, so that's 14 times -1, which is -14. Down below, I'm going to get a 1 minus, I got to square everything. So 2 squared is 4, and I squared is -1. Okay, so let's see. 6 minus 14 is -8, plus the 19i, and then down below it looks like I'm going to get 1, -4 times -1 is +4, so it's 1 plus 4. So I just get 5. Okay, and we got that next one done. Okay, so far so good. Let's see. All right, this guy, the fourth one down, so I'm going to have -5 over 9 plus I. Okay, let's see what we got going on here. Well, this guy looks real similar to this guy, because notice I have one term up above a monomial. Just like this, I have one term up above like a monomial. So when I multiply by the conjugate, it looks like I'm going to have to use a distributive property up in the numerator. Okay, so I've got this binomial with a complex number in it. Okay, so I got to multiply by its conjugate, which would be 9 minus I. So that means I got to do the same thing up above, 9 minus I. Okay, so let's see. I've got to use the distributive property here. Okay, so -5 times 9 is -45. -5 times -I is +5i. Down below, the o's and i's cancel each other off. We get a difference of squares, so I take the first term, square it, 9 squared, minus the second term squared, I squared. Okay, so we have a -45 plus 5i, and then down below, 9 squared is 81. Okay, notice this would be minus I squared. I squared is -1, so it'd be minus -1. And obviously this just becomes 81 plus 1, so we get 82 down below. Okay, so I get an 82. So I get -45 plus 5i all over 82. And we're in good shape. Okay, running out of room on this piece of paper. Let's go to a different one. Okay, I got these two left right up here. Okay, and notice that both of these are real similar to, like, for instance, number 1 and number 3. Okay, so let's see. That first one, 5 plus 2i over 10 minus I. Once again, I got to use a conjugate because this denominator is a binomial. The conjugate of 10 minus I is 10 plus I. So I got to multiply above and below by 10 plus I. Okay, let's see. All right, notice this numerator is a binomial. 10 plus I is a binomial, so that's FOIL method. All right, so first times first, 5 times 10 is 50. Outside, 5 times I is 5I. Inside, 2I times 10 is 20I. And last, 2I times I is 2I squared. Okay, down below, conjugates, when I multiply them, I get a difference of squares, so the O's and I's cancel each other out. So you just get first times first minus last times last. And then simplify. Okay, so let's see, I have 50. 5I plus 20I is 25I. And then notice this is going to be 2 times I squared, and I squared is -1, so that's 2 times -1, which is -2. Okay, down below, 10 squared is 100, minus I squared is -1. Okay, so let's see, 50 minus 2, you get your 48, plus 25I. And then down below 100, that would be 100 plus 1, so we get 101. And we are done. Down to the last one, I plus 2 over 3I plus 8. Again, notice the denominator is a binomial, so I've got to use a conjugate. The conjugate of 3I plus 8 is 3I minus 8. Again, in the numerators, I have a binomial and a binomial. That's the FOIL method. So let's go. First times first is 3I squared. Outside times outside is -8I. Inside times inside is 6I. And last times last is -16. Okay, down below, the O's and I's cancel each other out, so I just first times first minus last times last to get a difference of squares. So I get 3I squared minus 8 squared. And then we just simplify. Okay, so let's see. I've got 3I squared. Might as well simplify that right now. Remember, I squared is -1, so that's 3 times -1 or -3. Let's see, -8I plus 6I is -2I. Don't forget the -16. And let's see, down here, 3 squared is 9. I squared is -1 minus 64. Okay, so let's see, what are we going to get up here? Well, I've got the -2I, and then -3 and -16 give me -19. And then down below, I'm going to get 9 times -1, so that's a -9 minus 64. Oh, I like this guy. So let's see, we've got -2I minus 19. And let's see, -9 minus 64 is -73. All right, now, again, we don't like negatives down in our denominator. You never leave it there. So that's got to go up above. And when that negative sign comes up above, it applies to everything. So I've got to use the distributive property. So I've got to take that negative sign, which is just a -1, and distribute it through the numerator. So -1 times -2I is +2I. -1 times -19 is +19. And that's all over 73. And we are done. I like that guy. Okay, that will wrap it up for videos this week. See you in class.